So now we're going back and going to talk about some definitions. A matrix is in row echelon form when all the following are true. Reading from left to right, the first non-zero entry in each row is 1. This is referred to as the leading entry. Reading from left to right, the first non-zero entry of a row, leading entry occurs to the right of the first non-zero entries of all the preceding rows. And any rows that contain all zeros will be below all the rows that have non-zero entries. So these would be in, make sure they're in row echelon form. So notice I've got 1 here. And so the first non-zero number I come in from left to right on each row would be a 1. And the ones below here are to the right of the ones that are in the preceding rows. Similarly here, and here I have a row that's all zeros, so notice that's at the bottom. And we saw an example of that a little bit earlier. Nope, we did not. I lied. So both of these are in row echelon form. Now, what I want to do is actually get into this form. So notice this is row echelon form, but this is also called reduced row echelon form because all of the numbers above these ones are zeros. So a matrix is in reduced row echelon form, the matrix is in row echelon form, and all the entries in each column above the leading entries of 1 are zeros. And I want it in that form because then it's a piece of cake to read the answer. So here are some examples of the matrix that are in reduced row echelon form. And see, now it's really easy. X would be negative 14, Y would be 29, Z would be 9. X would be 6, Y would be 7, Z would be 3. A matrix in reduced echelon form, we can find the answer very easily just by reading it off. So the solution set is negative 16, 29, 9. When a matrix is written this way, we say that we have ones written along the main diagonals. This is referred to as the main diagonal. So to solve a system linear equation using the Gauss-Jordon elimination, we want to write the matrix that represents the solution of linear equations. Use elementary row operations to rewrite the matrix in reduced row echelon form. For a 2 by 3 matrix, this is done by you first get 1 in the top left corner. You may find it easier to first switch row 1 and number 2, and then divide every member in row number 1 by the entry in the first row, first column. The answer will be new row number 1. Next, you want to get 0 in the lower left corner. So you're working counterclockwise, stopping at the top left, and you work down to the bottom left. Multiply row number by the opposite of the entry in the second row, first column, and add the results to the second row. The answer is your new row number 2. Your third step is to get 1 in the entry for the second row, second column. You're going to divide every number in the second row by the entry in the second row, second column. The answer would be new row number 2. So now you're at the bottom right. And then finally, we're going to go to the top. We want to get 0 in the entry for the first row, second column. So we're going to multiply row number 2 by the opposite of the entry in the first row, second column, and add the results to the first row. The answer is your new row number 1. And once you have it, then you just go ahead and write your new system linear equation that corresponds to the matrix and write down the answer. So let's go back and to do some problems. And so this is kind of what we've gone over, just a little bit different explanation. So again, these would be row echelon form. These would be reduced row echelon form. So the first step when we're trying to solve a problem, we have to get everything into the proper form. So I need to get my equations into standard form. So like in this example, my first equation's fine, but my second one's a mess. I need to distribute that 3 to both terms. And then we need to go ahead and move the y's to the left side, move the 3 to the right side. So I'm going to subtract 3 from both sides and subtract 5y from both sides. That will give us 3x minus 5y equals 1. So my first equation is 2x plus 3y equals 7. My second equation is 3x minus 5y equals 1. So I now have our equations in standard form. Next, I want to write the augmented matrix. So I'm going to have 2, 3, 7, 3, negative 5, and 1. So now I've got my matrix. Now I'm ready to solve it. So remember, the first thing I want to get, so let's get our procedure over here from a couple pages ago. I want to get a 1 in the top left corner. Here I'm probably going to stick with this being my row number 1, because I'd rather divide by 2 than divide by 3. So what we're going to do then is we're going to divide every number in row number 1 by the entry in the first row, first column. So let's go ahead and write that out. So notation, I'm taking row 1 equals 1/2. I'm going to use lowercase here. I know it's a little bit different from the book. The book used capital letters throughout. I like to use lowercases because that just kind of tells me that's the old row number 1, and the uppercase would be for the new row number 1. So there is a method to my madness. So if I take 1/2 of the old row number 1, I'm taking that 2, 3, and 7, and I'm dividing them by 2. And that's going to give me my new row number 1. Which would be 1. Let's do it as a decimal, 1.5 and 3.5. So when I write this down, my second row still stays the same. I haven't done anything to it yet. But now my first row is 1, 1.5, 3.5. And then we've got our 3, negative 5, and 1. So we've now completed the first step. So let's go to our second step. I want to get a 0 in the lower left corner. So I want to multiply row number 1 by the opposite of the entry in the second row, first column, and add the result to the second row. And that's going to become my new row number 2. So I have a 3 down here, so I want to multiply row 1 by the opposite of 3. And I want to add that to row number 2. And my answer is going to be my new row number 2. So, in fact, let's color code this. So I'm going to take a negative 3 times row number 1. And let's see what we have. We have a negative 3, negative 4.5, and negative 10.5. I'm going to write down my row number 2, which would be 3, negative 5, and 1. And we're going to add these together. And that's going to give me my new row number 2. So that's 0, negative 9.5, and negative 9.5. So when I go down to write my matrix again, my row 1's still the same. But now my row 2 is this 0, negative 9.5, and negative 9.5. So now we've completed step number 2. So our next step is we need to get a 1 in the entry for the second row, second column. So I'm going to divide every number in row number 2 by the entry in the second row and second column. Well, so I'm going to divide by negative 9.5. So we have 0, negative 9.5, negative 9.5. I'm dividing that by negative 9.5. And that answer is going to give me my new row number 2, which would be 0, 1, 1. So row 1 still the same. And now row 2 I have 0, 1, 1. I've now completed the third step. My final step is I need to get a 0. Oops, sorry about that. I need to get a 0 in the first row, second column. I'm going to do that by multiplying row 2 by the opposite of the entry in the first row, second column, and add the results to the first row. So now I need to get 0 up here, so I'm going to multiply this by negative 1.5 and add it to row number 1. So let's just write that out. What we're doing, we're taking a negative 1.5, multiplying with row 2, and I'm going to add it to row number 1. And that answer is going to become my new row number 1. Okay, so this is 0, negative 1.5, negative 1.5. Did the wrong color, didn't I? My bad on that. Let me try that again. So that was 0, negative 1.5, negative 1.5. Row 1 is still this 1, 1.5, and 3.5. So when I add these together, that's 1, that's 0, and that becomes 2. So now, my matrix looks like this. And now I can read off the solution. Here, x has got to be equal to 2. Y has got to be equal to 1. So my solution would be the point 2, 1.